Welcome. In this demo, we will cover MuShop, a cloud-native application built and deployed on Oracle Cloud Infrastructure. Let's dive right into the application. As you can see, we are modeling an online shopping experience with this application. We have the usual services like a catalog, a cart, order management, and so on. The application is built on microservices and leverages the Oracle Autonomous Database. Let's take a look at the lifecycle for this application. As shown here, developers will submit code to the Oracle Developer Cloud Service or a third-party continuous integration and delivery system. The Developer Cloud Service will build new versions of the application images and deploy it to the Oracle Container Registry. The images are then transferred from the Oracle Container Registry to the Oracle Container Engine for Kubernetes, or OKE. This is where the application runs. Components like Service Broker enable managing cloud services like autonomous transaction processing directly from Kubernetes possible. Let's go back and take a look at the application architecture. We can see that the application is made up of various pods, and they are fully decoupled and written in a variety of languages. For instance, the catalog application is written in the Go language, whereas the cards application is written in Java, and they can communicate seamlessly with each other. Let's take a look at how this application is deployed in Kubernetes. Over in the Kubernetes dashboard, we can see that the various pods that make up our deployment. Different developers can create and update each of these microservices in parallel. You can also scale these microservices independently. For instance, during peak shopping seasons, you might probably want to scale the catalog much more than the shipping or order processing. To see what's behind the Kubernetes dashboard, the Kubernetes cluster itself, let's go to the Oracle Cloud Infrastructure console. Here we see the Kubernetes cluster. The Kubernetes cluster can run these workloads on pools of compute instances called node pools. Here we have a single node pool. Node pools help you manage capacity, patching, and so on. You can make changes to the infrastructure without affecting the applications. A quick note about Service Broker. So some microservices, such as orders and cards, depend on databases like the Oracle transaction processing to manage the application data. Oracle Container Engine supports the Service Broker for Kubernetes to create and manage these databases. The Service Broker lets the developers specify parameters like database size and auto-scaling options. Kubernetes will then create and manage the database. Let's look at the database a little bit more closely. Oracle offers a simple but powerful database as a service model. This is the Oracle Transaction Processing optimized for OLTP workloads. ATP provides automatic backups, patching, and auto-scaling. With ATP, you can significantly reduce the management overhead and total cost of ownership. ATP also exposes the metrics that it collects to the user. Let's take a look at the Performance Hub. Here we see that the various metrics that the database is collecting, and we can select and look at the data across a wide range of times and see what is actually happening to our database. We can see the various operations that are happening in the database and at what times and so on. We just saw how Oracle Cloud Infrastructure and Autonomous Database come together to provide a simple and holistic solution for microservices and data management. Thank you.